Good evening, I'm Mingming Zhao. My topic for my final project is Big Data Case Study in Life Science. This is my first course in Harvard Extension School. Hope I can do a good job in here. And introduce myself a little bit. I'm coming from mechanical engineering background and currently working in a diesel engine company for 5 years. I got a master's degree from Purdue University in mechanical engineering, and I'm enthusiastic in all kinds of automotive technologies. Right now, I'm trying to catch up big data and programming skills. Hopefully, I can get into big data field to be a data scientist or in a self-driving car industry. My hobby is to change myself from being like a CS guy to a real CS guy. The problem statement. This study is trying to investigate the relationship between life expectancy at birth of different countries and many other factors such as country area, population, economic condition, climate, and happiness index, all kinds of things. And hopefully, in the end, we could conclude some important factors which contributes most to life expectancy, and so that the people interested to improve their life expectancy could focus on those areas for those countries. So this is my goal. And the technology I used for this project is the Apache Hive. I use that because it is convenient and easier to handle tables using SQL in a regional database. And the other tool I use is the Spark machine learning library, as we taught in the school in the lecture. I use it to build my decision tree model and linear regression model to predict the life expectancy using different factors. And after using the Spark machine learning library, I feel it also very convenient to use the scikit-learn, which is a comprehensive Python machine learning toolkit, and for my data sets. And I use the scikit-learn inside Anaconda Spider, which is a very convenient Python IDE, and with all NumPy, SciPy, and the scikit-learn package pre-installed. So it's a very convenient tool. So for the datasets, I use datasets from the websites listed here, and I'm not going to go over them one by one. The size of my data is 1.5 MB and all in CSV file. So let's go to this problem solving. So step one, I identified the independent variable and the dependent variable. And of course, my dependent variable is life expectancy in years for each country. And my independent variable, or the X, are the area, the country area, and the education level, literacy. And the next three is to describe the land usage, whether they are used to raise rice, corn, or it's used for other like coffee, rubber, or the other kind of land usage. And then I have the data for climate, which describe it's dry or wet or something in the between. And I got data from birth rate and death rate. And then I'll have the labor force percent spent in agriculture or industry or service. And I also have the data for people's living condition, like freedom, how people have the freedom in their country, or how it's going for their life happiness score. And I have a GDP per capita as economic description for that country, and the population as well. And I have development level, region, major area as a categorical to describe how advanced economy is for that country. And I have a region as to show which part of continent it is for each country. And step two is to load the preliminary clean data into Hive. The reason I say it's preliminary cleaned is because when I have download data from websites, they are pretty a little bit messy. And the reason is, for example, the country name convention is different. For example, the North Korea, and some other file name as Korea, comma, North instead of North Korea. So all these kinds of things, for example, Congo. So those kind of countries, people have a different way to name it. So I need to make sure manually those names for each country are the same, and so that we can use it as a common column, so that I can merge table easily later. And also the other kind of things. For example, one column may have a letter instead of values in that column. So I need to manually make sure all these kind of things is cleaned. And with that, I can load into Hive, and then merge them, merge those specific columns which I'm interested in to a final table. And when I get final merger table, also I find there is some no columns. So I need to delete those rows so that my linear regression or decision tree model can work properly. Then I can get the final clean data. And here just a glance of it to show. I think I have 18 X with 1 Y, and I have country in the first column and the area in the second, all the kind of things followed by each other. So with that, we could go to do a decision tree or linear regression model and a Spark. So in order to make a Spark able to see Hive tables, so we need to do this way with a Hive context and with a CQ name, CQ to select them. And then, of course, we need to make sure the categorical columns are treated properly. Decision tree is easier because we can just simply convert those a string to a flow type and then wrap them in a NumPy array. And also, we usually select 90% as a train data set and 10% as a test data set. And then I build a decision tree model using Spark machine learning library, and then we can evaluate the performance of a decision tree. And on the right, it's my visualization for my decision tree. Is x-axis is the actual data for my test data sets, and the right vertical is the predicted. So they follow the 45-degree line, not too bad. And I can demo how my script look like. It's basically just I load those kind of things in and then make sure I define the right function, because I need to handle those categorical columns, and then define my feature, and then I define my y, and then split them in 90%, 10%, and then build the model for the decision tree model, and then we can see how it is. So in my quick VM, I just run, and I can show you. For my decision tree, I have 112 for train dataset, and the test dataset is 12. And my actual prediction is like I have actual is 55, and prediction 56. I have like 73 as actual, and 74 is a predicted. So not too bad. I have default 5 depths for decision tree at 47 node, and has MSE, MAE, and all these kind of performance evaluation. And I can also see those decision tree model. It basically is the if-else sentences, and I have 47 nodes. So this is my decision tree, and with that, I think it will be good to do a linear regression using Spark machine learning library. And of course, we need to do a special process for the binary encoding for categorical, since we are running linear regression. And but I have been struggled a lot to find a good iteration and a number step size to make a linear regression give me a valid number. It is so difficult. I keep getting nan for those weights, so I decided not using this and go to scikit-learn under Python. And I installed an encoder from website. Since I'm using Windows, I just click the right version, and once I have installed it and I have a launch and a encoder, it comes with a spider, so I can just click launch to launch my spider as my Python IDE. So as I said, the scikit-learn is a very easy tool to catch up And the key code actually I already showed on the slides is from sklearn, we import the datasets and the linear model, and then with the linear model we can call the linear regression function. And then we can just call another method under linear regression is fit with the X chain and the Y chain. And I have my demo shown here. So I already have loaded my CSV file, raw file here back in. So just show you a little bit. So my shape of my chain datasets and the test datasets like this, and I can run regression very easily. And then it will give us how the coefficients are, and then my R-square for my chain datasets is 91%, and my test datasets, the R-square is 89.99%. So it's both around 90%. It's not too bad. So and we can also see the coefficients relation to their X correspondingly. And for the visualization, this is plot for the chain datasets, the actual versus the predicted. They follow 45-degree line pretty well. And for my test datasets, pretty well too. And because both R-square is close to 90, as we have been seeing there. So, and we can see some MSE, RMSE, MAE, all those kind of things. And then also the residual plot close to 0. And a very interesting thing is scikit-learn toolkit provide us an ANOVA table for F-score and p-value. And this basically tells which parameters or factors are most significant statistically to determine the Y, or the life expectancy. So, and we can use this to study which ones are the most interesting factors. So, and if we go back to the point, so as I already mentioned, this is the R-square. We're gonna go to the next slide. So we have a p-value, and if we sort p-value from very small to the bigger, and we can identify the most important factors. And we identified the major area of Africa, birth rate, death rate, world happiness score, GDP, literacy, and agriculture and development level list is the most important ones. So in a summary, a good linear relation is identified between life expectancy and the factors. And those factors we mentioned in the last slides. And actually, I do a little bit of study on the Wikipedia and the United Nations websites. It shows, for example, why the first factor is the major area Africa. And because in Africa, they have a lot of public diseases and even like HIVs, which limits people's life expectancy. And another interesting finding is the happiness score and the literacy is a surprising factor. But in a nutshell, I think on the other hand, it makes sense because when people have more knowledge, people probably can make a better living and to understand how to make a living. And the issue is, I think the independent variable here I have does not mean they are completely decoupled, completely independent. So, but it's beyond my study for this project, I think. So for the summary and the learning from these tools or technology, I feel like the cleaning data sets is super important. And all the raw data coming from all kinds of sources is a little messy, and we need to spend a lot of time actually to make it clean. And the second bullet is the decision tree overall performs good, but it's so easy to overfitting the model, and it also hides the important factors. And sometimes people are very interested to know which factors are important. And the Spark machine learning library is, I think, is a good model, is a good one, but at least for my case specifically, it's not very convenient for linear regression because it spends so much time to find the step size and the iteration numbers. It's not very convenient for me. But scikit-learn, to compare with machine learning library and the Spark, scikit-learn is very convenient, and also it provides a good visualization package built on the top of matplotlib library. So in a nutshell, I think I learned how to use scikit-learn, and it's very easy to use and very useful. So I think finally, for this project, I use these kind of tools, and I think also solve some practical problems. Hopefully, the decision maker in a country who want to improve people's life expectancy could focus on something like the public diseases and improve the medical equipment level to improve birth rate and make people happier, and develop the education, develop the agriculture. Hope people can get life expectancy longer. So that concludes my video. So hope everybody enjoys. Thank you.